All right. Just as a reminder, guys, we are recording, so please make sure that you are quiet. Shh. Talking about rationalizing the denominator. So we had some questions on IXL that when you tried to take the square root, it wasn't a perfect square for the denominator. And when you tried to simplify, it couldn't simplify to a perfect square root for the denominator. So in those situations, we have to fall back to what we call rationalizing the denominator. You are not allowed to have a square root in your denominator. So one of the questions that constantly kept getting messaged to me over the weekend was the following problem. Square root of 5 over 12. Okay, so in a problem like this, 12 is not perfect, and you cannot simplify 5 over 12. So when you have a situation like this, what you have to do is break it apart and do what we call rationalizing for the denominator. Now there's two different ways that we could focus on rationalizing. You could try and simplify 12 as much as you want at first, so then you're working with smaller numbers to have to break down. Or you could work with the 12 and then simplify at the end. I'm going to show you both ways. And you pick which one you would prefer to do. So the first way, break them apart. Square root of 5 over square root of 12 would be the original problem. And then even though 12 is not a perfect square, I can break it apart into two factors, one of them being a perfect square and one of them not. Who can tell me what the two factors of 12 are? Nathan? 3 and 4. So I know I can break this up as the square root of 4 and the square root of 3. Square root of 5 would stay the same as it is on the top. Now that I have that, I can go ahead and simplify that one perfect square that I do have, which is the 4. So this would then become the square root of 5 over 2 and then square root of 3. And the problem lies in the fact that I'm not allowed to have that square root of 3. So what I would then have to do is I would have to multiply both the numerator and the denominator by that square root. So I would multiply by square root of 3 with my numerator, and I would multiply by the square root of 3 with my denominator. So now for my numerator, I'm going to have the square root of 5 times 3 over 2 times the square root of 3 times 3. What's 5 times 3? 15. So I have the square root of 15 over 2 times the square root of, what's 3 times 3? 9. Now I still have a square root in my denominator, but is that a perfect square? Yeah. What is the square root of 9? 3. So now I've got the square root of 15 over 2 times 3. And what's 2 times 3? 6. So this becomes the square root of 15 over 6. And there's my final answer. 15 cannot be broken up because of the fact that 5 and 3 cannot be broken up. Okay, so that's the first way that you could do it. The second way, dealing with the square root of 5 over the square root of 12, is instead of simplifying and then rationalizing and then simplifying again, you could rationalize first and then only have to simplify once. So rationalizing first would entail that I would multiply by the square root of 12 on both the top and the bottom for my numerator and my denominator. So this would give me the square root of 5 times 12 over the square root of 12 times 12. What's 5 times 12? 60. And what's 12 times 12? 144. Okay, now I know that 144 is perfect, so I don't have to worry about breaking it up. But 60 is not perfect, but it does have a perfect factor. Who can tell me what are the two factors for a square root of 60? Huh? 4 times 15. So we have 4 and we have 15 over the square root of 144, which is perfect. And I know that the square root of 4 is also perfect. So what is the square root of 4? 2. So we have 2 square root of 15 over, what's the square root of 144? 12. And now I can simplify. 2 and 12 are both divisible by what? 2. They're both divisible by 2. So that would give me, if I do 2 divided by 2, I'm left with 1. Do I have to put the 1? No. So I'm left with the square root of 15 over, what's 12 divided by 2? 6. And there's my final answer. They are the same. It's just a matter of what would you prefer to do. All right. Let's say that we have the square root of 7 over 2. Again, 2 is not perfect, and you cannot simplify 7 and 2. So the best thing you can do, separate them, square root of 7 over square root of 2, and then rationalize. What are we going to do to rationalize? Annalise?
Multiply the square root of 2 times the numerator.
Okay. Multiply by the square root of 2 to the numerator, and also to the denominator. So that's going to leave us with the square root of 7 times 2 over the square root of 2 times 2. What's 7 times 2? 14. So we get square root of 14. What's 2 times 2? 4. So we get square root of 4. Now we have a perfect square for our denominator. What's the square root of 4? 2. Can square root of 14 be broken up? No. So square root of 14 is as simplified as that's going to get. That's your final answer. Yeah.
For an example that we used for A,
Uh-huh.
can you just multiply the numerator and denominator by square root of 12?
That's what we did for B.
Oh, I didn't know.
All right. Let's say I have 2 square roots of 80 over the square root of 7. I want you guys to go ahead and simplify that one on your own. All right, who can tell me what they got for problem number 3? Grant?
8 square root of 35 over 7.
Very good. 8 square root of 35 over 7. So let's go ahead and take a look. First thing that we note, square root of 7, it's not perfect, can't be simplified, so we're going to go ahead and rationalize with it. We're going to multiply both the numerator and the denominator by the square root of 7. That's going to give us 2, I'm going to go ahead and put 2 in blue because it's already done, times the square root of 80 times 7. What's 80 times 7? 560. So we have 2 square roots of 560 over the square root of 49. Now 49 is perfect. 560 can also be broken up into perfect squares. Who can tell me what are the factors for 560? Arisaea? 4 and 90 would work. No, 4 and 90 is not it. Because 4 times 90 is 360. We want 560. Joshua? Still something larger than 4. There is a larger factor than 4. Nathan?
16 and 35.
16 and 35. So square root of 16 is the largest perfect square that's going to go into it. So we'll have square root of 16 and the square root of 35. All of it over the square root of 49. Okay, so now we've got 2 perfect squares. Square root of 16 is perfect, square root of 49 is perfect. So that's going to leave us with 2 times 4, and then you still have the square root of 35 over 7. Well, 2 times 4, you can actually work that out. 2 times 4 is going to give you 8. So you have 8 square root of 35 over 7. And the only thing inside the square root is that 35. And then you're done. All right. Now, sometimes it's just numbers. Other times, you've got some variables involved. So let's take a look at a couple practice problems with variables. I know. So let's say that we have the square root of 13 over the square root of 50t. Okay, so I know that 50 is not perfect. I do know it has a perfect square inside of it, but I'm going to go ahead and just multiply by square root of 50t. It makes my life a little bit easier, so I'm not having to simplify, rationalize, and simplify again. I'd rather rationalize, so I'd rather follow plan B than plan A. To me, plan B is shorter, and I like to make sure that I have enough time to be able to work on everything. So I like plan B better. So what I'm going to do is I'm going to multiply both the numerator and the denominator by square root of 50t. The only problem with plan B is that means you're now working with larger numbers to have to break down in your numerator. That's the only problem. Okay? So when I multiply 13 times 50t, well, what's 13 times 50 going to give me? 650. So I have the square root of 650, but I don't want to forget the t. All of it's going to be over 50t times 50t is going to give me what? What's 50 times 50? 2,500. And then t times t is t squared. Let me zoom in so you guys can see it a little bit better. Okay, so now we have the square root of 650t over the square root of 200 or 2,500t squared. This right here is a perfect square. Now, square root of 650 can actually be broken up. Square root of 650 can be broken up. And guys, in times like this, even though you're trying to work it all out, you can technically use your calculator for a little bit. You can use your calculator for the square root of 650. You don't want to type in your fractions, but you can do the square root of 650 in your calculator and then simplify that later. So who can tell me square root of 650? Type it in your calculator. What do you get? There you go. So you get 5 square roots of 26. So we know that this is going to become 5 square roots of 26. Now t has to be left in there because it's not a perfect square. And then what about the square root of 2,500? What does that become? 50, and then the t squared becomes t. So this becomes 50t. All right, now can we simplify anything? Yeah. Anything that's not inside of a square root can technically be simplified. 5 over 50, that's what you're wanting to focus on. This 5 over 50 can be simplified. What are they both simplified by? 5. So I can divide this by 5, I can divide this by 5. 5 divided by 5 is just going to leave me with that square root of 26t. And then 50 divided by 5 is going to leave me with 10, and then I have t at the bottom. There's my final answer. You can use your calculators for the numbers, but you can't use your calculators for the variables. And you can't use your calculator to type in a fraction, but you can type the numerator in separately, and you can type the denominator in separately, and then simplify accordingly. Grant?
Can't you divide the decimal variables?
No, because one of them's inside of the root, and one of them's outside of the root.
That can become t to the second power and just be inside the root as well.
Yes, but if you decided to simplify it as t over t to the second, then you'd be left with t inside of a square root in your denominator, and you'd have to multiply by the square root of t to rationalize that. Remember, you don't want to simplify if it's perfect. If the denominator is perfect, leave it alone, because you cannot have a square root in your denominator. Okay? Huh? Why do we have to square? Why do we have t squared at the bottom? Because t times t is t to the second power. All right. We'll do one more with a variable. All right, square root of 32 over the square root of 48x. Now, again, I know that they're not perfect, and I don't want to sit here and simplify, rationalize, and simplify, so I'm just going to rationalize right off the bat. I'm going to go ahead and multiply by the square root of 48x to both my numerator and my denominator. So what is 32 times 48? 32 times 48 is what?
1,536.
Oh, I thought somebody said 2,000. I was like, 1,536. We still have that x. And then the square root of 48x times the square root of 48x. So 48 times 48 is going to give us 2,304. And then x times x is x to the second. Okay, so now I know I've got a perfect square in my denominator. Let's go ahead and simplify the square root of 1,536. So just type in your calculator, square root 1,536, and hit enter. Really? Now you choose to do a decimal. Okay, so you're not going to have problems this large in your calculator.
Can you do square root of 100 or square root? No, square root of 1,000.
Can you do square root of what?
Square root of 1,000, and then you do square root of 500. And square root of 10, and square root of 6.
All right, well, the largest perfect square that's going to go into it is 256. So you can break this up as a square root of 256, and then the square root of 6x. All right, so then here's our perfect squares. We have the square root of 256, and we have the square root of 2,304, x to the second power. Square root of 256 is going to give us 16. The square root of 2,304 is going to give us 48. And then the square root of x to the second power is going to give us x. In our numerator, we still have that square root of 6x that's not perfect. Now we focus on simplifying if we can. What can be simplified? 16 over 48. They're both divisible by? Well, they're both divisible by 16 also. They're both divisible by 16. 16 divided by 16 is going to give us 1, so we're left with the square root of 6x as the numerator. And then 48 divided by 16 is going to give us 3, so we have 3x as our denominator, and that's it. All right, your assignment. I'll call it homework, but you've got plenty of time to be able to work on it in class. You do not have pride with me today. It's not Monday.
Whoa.
It's not Monday. It's Tuesday.
Oh, yeah, I forgot. It's Tuesday.
Shh.
Can I come early and do the homework with you?
With me?
Yeah.
No.
I don't understand.
You are going to have plenty of problems that are simple. I'm only going to have a couple of them with the variables. The variables, I think, are the hardest ones. But you're going to have majority of your assignment is going to be with just numbers. This is not on your milestones this year, but it will be on it next year. Shh. Hey, guys. Getting too loud.
So milestones is only what we learned last year.
Huh?
Milestones is only kind of what we learned last year.
Milestones is based off of 7th grade standard materials. So it's what you learned from first semester, and it's what you learned from your second semester in 6th grade. For those of you who are in accelerated, you will have plenty of time to be able to practice and review, because I have different milestone preps, and everyone will have an IXL account again prior to milestones with standards that you can do for practice. Yes, sir? I said that they're piloting the CEPT exam in the hopes that it might replace the milestones in the future. Not yet. Shh. Quiet. Quiet. I don't understand why you guys don't know what quiet means. That's a 300, by the way. It's 2 over the square root of 300, in case you can't see it. Yes, sir. What, the milestones? I have no idea, honey. All I know is that we were told to go ahead and administer it, and 7th grade is the only ones administering it. Last year, or for 2 years prior to this year, so not last year but the year before is when they started piloting it. They piloted it for 2 years with a certain 7th grade class on the other team. This year, all of 7th grade across the county had to do it. Next year, all of 6th and 7th grade have to do it. They have to collect enough data to see how it goes. Right now, the scores off of it were not good. So it's not likely that they're going to be using it. So the next step is they might use it to replace the interims.
Why did they
Well, because as times change, education changes too. So there's not as much emphasis placed onto things that now can be calculated with a phone or an app. More emphasis has to be placed in other areas then. Yes?
So in the future, like the people that already graduated and the people that never had to take the Georgia milestone but have to do the CRCT, does that mean like we're gonna have better education than that?
Not necessarily.
We're doing 12. They all suck at this.
I know.
Shh. Quiet, guys. I love how some of you are sucking your teeth at me as if I am doing you a horrible service of having you have to do this work.
Whatever you do, do not say Go try to
Quiet. Hey, I know you can hear me. Quiet. There you go.